polymers are plastics. Essentially your plastic bags, garbage bags, that stuff. That's a class of materials. And you've got glass. What is glass? What kind of material do you think that is, glass? Your pottery, clay pottery. I heard something. Did you say something?
Dirt or soil.
Dirt or soil?
Ceramics.
Okay. You got it. So actually ceramics. Ceramics. 3 classes of materials. And then you've got something called composites, which is a combination of any of the above. So metal, polymer, polymer, ceramic, or ceramic metal system, that would be considered a composite. So wood is a composite, because it's a mixture of combination of these. So what are some properties of those? I'll just show you here. So if you think about a metal, what sort of properties does it have? You've got high melting and boiling points, right? You can melt a metal, or that you can melt it, and that's how you would form it, right? And so it's very conductive, as opposed to ceramics and polymers. So polymers are the least conductive. They don't conduct any electricity. Ceramics are in between because they have electrons inside, and if you've taken physics, the electron movement causes the conductivity, but the ceramics are in between. And also, it conducts heat in that way, and it's reversed. So the ceramics have the least amount of conductivity compared to metals and polymers, or heat conductivity. And polymers have the least amount of actual electric conductivity. And so metals, if you look at the outer structure of it, it's very hard, but when you're making it, it's actually malleable. So if you take another metal and you can push it, and you can form it into these shapes, curved like this. And you've got all these joints, so you can make very intricate structures. So you can cut a hexagonal out of it. You can use dye and cut different things. And so, yeah, you're able to make it into a shape like this very easily. And polymers too, right? Polymers are soft, like your garbage bag. You can shake it and stretch it and everything. But it's because you're making it with more either organic or inorganic blocks, which we can talk about if you're interested in chemistry. And so let's go over some examples of different types of metals. Since I guess you haven't had this before, I can just talk about the different kinds of metals they use. So they use titanium, and cobalt chrome, and also stainless steel. So what do you guys think is an important property about, or that's really the most striking thing to you about a metal? Like if you leave it outside in the rain, what happens to it?
Rust.
It rusts, right? It corrodes. And that's a really bad thing for the human body. Corrosion is a very, very tough issue to deal with, because if you say you put iron, right, it oxidizes. So basically what happens is the oxygen causes it to erode away. And when you have that in your body's not going to deal with that rust very well. It's a byproduct, and so it's going to end up doing damage, and it's not going to react very well with your cells. Your immune system is going to attack that right away. So you want something that's not corrosive. So these metals are deemed biocompatible, which means that they don't erode, they don't cause these toxic side effects. So these are very commonly used in orthopedics. So they're your 3 standard metals. And then you also have different metals that you use for dental industry. So you have something, and you can have alloys in metals. Has anyone heard of alloys? So what is an alloy? You're nodding your head.
Like a mixture of metals.
Right. So it's a mixture of different kinds of metals. And so you've got alloys. There's such as I can't even say this word right, amalgam, which is used in dental fillings. And that's a mixture of mercury, silver, and tin. Okay? And then your gold too, of course, your gold. So these 2 are dental implants, and these 3 are orthopedics. Okay? And so the most common ways you would process and make these would be casting, or you'd machine them. Just like I said, with dyes, in mills, just kind of chop away at it and form it into the shape that you're very interested in using. So that's important for your body. You got to make something the right size and the right shape. So those are the metals that we're interested in. So we'll move to polymers, plastics. So can anyone think of any specific plastics? So what is a plastic? Very basic. Yeah, go ahead.
Would silicone be?
So silicone is in the class of polymers. It's more complex structure. So that's one of them. It's an example. So it's a good example, silicone. That's used for a lot of implants. Polymers are made up of small monomers, like a structural unit, very small, and makes up a lot of them. So the very simple polymer, if you guys have done chemistry, it's just carbon to carbon, and you have hydrogens bonded like this, and it's just a chain. So this is the structure, and it basically basically goes on to infinity, or however long you want to make it. So there's carbon blocks. This is an organic polymer. You have two carbons, and they're attached, hydrogens are attached, and you just increase the chain, so you extend it. And that makes long, flexible strands, and that's what makes your plastic so soft and able to be moved around. So long chain of molecules from there, that's what this is. So organics such as carbon. And so you can attach other funny things on here, like fluoride, fluorine, chlorine, and that will give you different, PVC. You all heard of PVC, right? PVC tubes. That's chlorine here. Okay, so you just attach different things to your chain, and your chain starts out with just one of these, and then just keeps going, and that's what makes your polymer. Okay, so I'll just give you some examples, since you haven't learned a lot of materials, different types of materials looks like in your background. So you have Teflon, right, very slippery. Water does not like that surface. It just flows right off. So Teflon, and it's coating a lot of your pans, non-stick pans, that's what they used. It's Teflon. Okay, and you have, more simply, just different kinds of structures you have would be like scaffolds. Does anyone know what a scaffold is? Yes, scaffolding is also in the paint industry. So scaffolds is just a type of structure. And so we have in biomaterials, you have scaffold too. And that would mean like a porous, spongy type of thing. So you've got a structure that's got holes in it. And so fluids can flow in and out of that. And that's really important for tissues. Right? You can make films or coatings. So coating something to make it more suitable for your environment, hydrophobic. Does everyone know what hydrophobic and hydrophilic means? Yeah, so liking water is hydrophilic, not liking water is hydrophobic, right? So scaffolds and films. So you can coat it to have that sort of function. And another category would be biopolymers. So natural things in your body that are, your body makes these polymers on its own. And so, I won't get into those. But basically you have proteins and sugars, polysaccharides. So those are in the class of polymers. And ceramics, our last group, basically, what I was saying, examples of those would be like glass, right? And actually the components of glass are oxides. And so they're combined with metals. So it's an ionic material because, does anyone know what an ionic material is? And give me the definition of ions. The chemistry people who like chemistry. What is an ion? What would an ionic material be? What chemistry people go? Like chemistry. So, does anyone want to try? You can try at least.
It's like an atom, yeah, like a charged atom.
Yes, okay, that's important. Okay, charged atom. So you've got one charged atom, and then you've got an ion, another, so electrostatic attraction or repulsion between an interaction.
Positive and negative.
Positive and negative, good. So you've got like something like a sodium, right? And then you've got something like chloride, negative. Okay, and they interact with each other, and there's some kind of interaction going on there. And that creates an ionic material, so plus and a minus. And so this is the basic building block of a ceramic instead. And this interaction is actually what makes it very brittle and very hard. Because you take a piece of pottery, you throw it on the ground, it breaks, right? Polymer's not going to do that, and metal's not going to do that. And this is because of these types of interactions. Okay? So something like glass, oxides, and so salts too. So NaCl is just table salt. And that's an example also of a ceramic, surprisingly. Right? And so one important one is bone. Bone is considered a ceramic material, and it's made up of hydroxyapatite. I won't get into the structure, that's because you haven't had a lot of chemistry. How you would do this, how would you make a ceramic? Does anyone have an idea? Or want to guess?
No.
Want to guess how a ceramic is made?
Just bake it in oil.
Bake it. Good. So what's the starting thing? Like, do you already just like have material and bake it?
No, okay, like form it.
Yeah, you'd form it from
Stuff.
Okay, so metals, talked about, if you heat it to really high temperature, it melts. So it becomes a liquid. So for ceramics, the difference is it's a powder. And so you bake the powder, and it becomes hard. So you're really close. You just bake it. But you would start with the powder here, and you'd be able to add a liquid there, because the melting temperatures are different for those. So that's a little bit of material science. See, we're going to cover all the grounds today. So material science.